Alright, so we have our list of queries here, and the first query is to get the count of observations during each season using a CTE, and the CTE is included within these parentheses right here. Of course, fall, winter, spring, summer. And then we select the season, the count of season, and that's how we get the output down here. The next query is to select the count of rose-breasted grosbeaks, which is one of my favorite birds. So we select the name, we join the observations table and the bird species table, and we select where the name is like rose-breast, and that should give us an output of rose-breasted grosbeak 202. The next query is find the number of some birds of prey. Note, not all hawks have the name hawk, so some will be left out. For example, northern harrier, common buzzard. Those are two off the top of my head that I know that don't have the word hawk in them. So it's not completely accurate, but this is not a real data set as is, so it's just for demonstration purposes. So we select and we have a case statement where the hawk, or where the name is like hawk, where name is like owl, where name is like eagle, and where name is like falcon. And then in addition to that, we have name in American kestrel or merlin, which are two species of falcons. Else, it will be no raptor, and that will be raptor category as an alias. And then we sum up the species count, or the quantity of birds seen for each raptor category, and we group by raptor category. And that gives us the most common category is no raptor, which would make sense. The second most common is owl, then hawk, falcon, eagle. Interesting. And by the way, I should say that that there are about 8,394 rows in this data set, according to my recollection. I just ran a query and added up the seasons. If you add up the count from the seasons, it's 8,394. So there are 8,394 total records in this data set. Alright, so the next query is find the top 5 states based upon observations. And we're going to do that by finding the number of observation IDs, distinct observation IDs, because the same observation ID could have occurred multiple times, and actually does. I mean, it does occur multiple times in the data set because each ID is linked to a different bird scene. So it could be observation ID 1 saw blue jay, observation ID saw a falcon, observation ID saw a cardinal, But so let's run this. And the top 5 states with the number of observations are New Jersey, Texas, Rhode Island, California, and Ohio. And in total, there are about 301. There are 301 observation IDs, distinct observation IDs from 1 to 301. And so we have a lot of overlap with people who, let's say, birded in New Jersey, and then maybe they birded in Texas as well. The next query is finding the number of endangered birds in the West. And I have a note here that not all states are included in this data set. There's only 41. And this may not exactly correspond with the official definition of what makes a state in the western region, but I chose the states of California, Oregon, Washington, Nevada, Utah, Arizona, New Mexico, Montana, Idaho, Colorado, and Wyoming. So we're going to find the number of birds that are endangered in those states, and I consider those to be a western region. And there's 54 endangered. The next query uses another CTE, and we're going to find the most popular bird for each state based on the greatest bird count for species in a state. So what that's going to do is we're going to find the name, the state, the number of the count for that, the count for species, all the species that were spotted in that state. That we're going to give that the alias of number spotted, and then we're going to rank each. We're going to partition by state and run the rank function over it, and get the species count for each state, and where the species that is the most spotted will have the rank 1, and the second most spotted species will be rank 2, and then the third most spotted species will be rank 3, and so forth. So we do that in the CTE. And of course, we're joining tables, and we're going to group by the name because we want to group by species and the state, because we want species state, and then rank, species state, rank, species state, rank. And then we're going to select from that CTE the name, the state, the number spotted from the CTE, but only where the rank is 1, because we have the column up here that identifies the rank of each species per state, and we want all the number 1 ranked birds per state. And so if we want to run this query, you'll see what that means. And of course, some states had multiple species that are tied for the same spot, so that's why we have multiple occurrences. So like in Alabama, the tricolored heron, Carolina chickadee, and the tufted titmouse were all a count of 11 of those species were seen, so that they tied for the first place. Then we have Alaska with the great white egret at 32. Arizona has 2 top species, northern parula and American goldfinch, tied for 41, and so forth and so on for all of the states. And again, I think there's only 41 states in this data set, so not every state's going to be included. Alright, so find the average flight speed and weight for birds that have European or Eurasian in their names compared to all other birds. And just because a bird doesn't have European or Eurasian, that doesn't necessarily mean that it's a United States bird. For example, the Canada jay. The Canada jay may cross into the U.S., but obviously, based upon its name, it's a non-U.S. bird primarily, but I could be wrong on that. So we're just going to compare birds with the name of European or Eurasian compared to birds that don't have that. And we're just going to assume that if they don't have that, they're American, even though that may not be correct. So we have two smaller queries. We have the average flight speed and the average weight in ounces for the European and Eurasian birds, and we're going to union that with the same kind of query, except we're going to filter out where the name is not like European and not like Eurasian. So and that would be for the American nationality. Let's see, and we get the average flight speed for the European is 39.52, and we're going to assume miles per hour. The average rate in ounces is 8.91. The American is 30.12 average flight speed in miles per hour and 10.16 ounces. So American birds, which is for sake of argument, say that they're heavier, but a little slower than the European counterparts. Or European birds, I should say, in general. And of course, there's going to be, in this data set, more American birds and less European birds. So the next query is finding the total number of birds that were heard but not photographed, photographed but not heard, photographed and heard, and neither photographed, I should say, nor heard. So we're going to have a case statement where we check to see if the bird made a sound and what kind of camera was used. If it was no camera was used, or if there was a camera that was used, and we're going to check that by using these statements right here. The alias of observation category will record those results, and then we're going to select the species count for the total number of birds observed in that category, and we're going to group by the observation category and see what the results are. So the most common one was heard and heard and picture. Not heard but picture was second. Not heard and no picture was third, and heard but no picture was the last with only 26. Alright, here's a simple one. Find the total number of birds photographed per camera. So that's just a matter of selecting the camera and then the species count. So then total number of birds seen with the camera, and then we're going to group by camera to get the results per camera. And most common was Canon, second was Nikon, third was phone, fourth was none, meaning that there's no photograph taken. Next was Panasonic, and then last was a Sony camera. Here's another easy one. Find all one-word bird names, aka no spaces. So again, this may not be completely accurate because I listed the cardinal as just cardinal rather than northern cardinal. Probably should have done northern cardinal since that's the official name. But we're just going to select the name from the bird species where the name is not like, and then doesn't have a space in it. So Dunlin, Veery, Merlin, Osprey, Mallard, Flamingo, Limpkin, Raven. These are all common, or these are all one-word names. But again, this probably should be common raven, and Flamingo probably has pink in it in front of its name or whatever, but it's just for demonstration purposes. We're going to show the total bird count observations per year in Maine. So that means using the year function to cut off the date. And we're going to sum up the species and then group by the observation year to get the total count of the number of species per year. And then we're going to filter by state equal to Maine. In 2017, there was 168, 2018, 155, 2019, 282 birds, 2020, 270 birds, and 2021, 260 birds. So 5 years later, or I should say 4 years later, the birds were, the overall bird count had increased slightly. And then the last query here is find all J counts per year. So this includes all J's. So I included in my data set blue jays, I think the green jay, possibly the turquoise jay, Canada jay, Florida scrub jay, Steller's jay. So basically, we're going to find per year the number of jays per year, and we're also going to say the number of jays per species. So we're not going to just parse it out by total count. We're going to parse it out by name. So blue jay will have a count, Steller's jay will have a count, green jay will have a count for each year, and yeah, let's just run it to see what outputs. So the first, it's ordered by the observed year, ascending, and then the number of jays is the secondary descending ordering function or ordering parameter. And we have in 2017 the Steller's jay was the most popular jay at 104. Then the turquoise jay at 68, then blue jay 63. So obviously you can see for 2017, and then 2018 turquoise jay was most popular. 2019 turquoise jay was more popular. 2020 blue jay was the most popular. 2021 Canada jay was the most popular. And you see the different jays listed out per year. I mean, I guess if you really wanted to, I could have done like a partition by year, ordered by number of jays descending, and then done something similar to what I did above in another query where I take the rank of it, and then I only take the top 1 or 2 jays, or maybe 3, however many you want per year. But I decided to just list it out. I mean, this is fine the way it's listed out. So that's all my queries. I hope that I demonstrated them adequately. I should say that the first one up here, I was able to find the seasons by taking the observed date or the observation date and using the month and day functions of the observation date in order to calculate, okay, which days are greater than 12/21, greater than or equal to 12/21, or in January, February, or less than March 21st. Okay, we'll put that as winter. And then same thing for spring. What days are greater than 3/21, or what dates are in April or May, or if they're in June, are they less than June 21st, and then we'll mark that as spring. And something similar was done for summer and fall, so that I could manually parse out the dates or the seasons for each date. I thought that would have been a good exercise for me to do, so when I was doing my Excel data entry and generating the fake data, I purposely tried to, and I also made a note in the README section of GitHub that I use Python, a very small portion, to help me out with generating the dates. But the point that I wanted to have the dates in a certain format that MySQL would accept, so that would be year, month, day. But I did not want to parse out the seasons then, because I wanted to do it in MySQL and see how it would be done. And it was really tedious, but it's probably a more efficient way of doing it, but this is the way that worked for me, so I'm going to go with it. Anyways, so that concludes this video, and yeah, just check out the code on GitHub and read the README if you have any more questions.